Last lesson we looked at displacement time graphs. What about velocity time graphs? Well, there's a little bit more to it than that. First, let's draw one out. A car is moving along a straight road. When t equals 0, the car passes at point A with velocity 10 meters per second. And this velocity is maintained until t equals 30 meters per second. The driver then applies the brakes and the car decelerates uniformly, continuing to rest at t equals 42 seconds. So sketch the velocity time graph. Right, so first thing we need is velocity v in meters per second. And we need time t in seconds. All right. We know that it's passing through point A at 10 meters per second. So let's label that on our diagram. 10, right? And we continue that all the way until t equals 30 seconds. Okay. Now, at 30 seconds, it's going to decelerate until rest. So it's going to go something like this. It slows down until it reaches rest. So how are we going to find the distance A to B? And this is 42. Remember this till the end of time. For a velocity time graph, if v equals f of t, right? The displacement is equal to the integral f of t, right? Which is the area, right? And the acceleration is going to be the differential of t, okay? Which is the gradient. So in order to find the distance, we need to find the area. 10 times 30 is 300. 42 minus 30 times 10 divided by 2. Well, that's the same as 6 times 10. 60. So therefore, the distance AB is equal to 360 meters. Okay, and all we did was find out the area. Is this video helpful? Well, make sure you subscribe so you never miss a video like it from me. Now let's look at this example. A particle moves 100 meters in a straight line. The diagram is a sketch of a velocity time graph. It starts with u and it accelerates to 10, right? The velocity is 10, right? And is maintained for 7 seconds. And then it decelerates to rest in 2 seconds. So the question is, find the value of u and then find the acceleration of the first 3 seconds of motion. What we can do is first find this area here, okay? The way we do that is we can work out the area here and the area here. So let's take a look at this, right? This is 7. 7 times 10 is 70, right? And we know that this is 7. This is 10 and this is 12. So this is 2 times 10 over 2. It's going to be 10. So we know here, this is 20 meters, okay? Now, what we can do is we can work out this as an area function. So, think about the equation of a trapezium. So this is our trapezium. We don't know what u is. We know this is 10 and we know this is 3, right? The area equals a half u plus 10 times 3, which is also equal to 20. So what we can do is solve this equation. First thing I'm going to do is I'm going to times both sides by 2. So 40 is equal to 3 u plus 10. Okay. Then I'm going to divide by 3. So u plus 10 is equal to 40 over 3. And so therefore u is equal to 40 over 3 minus 10. And if you plug that into your calculator, we get an answer of 3.33 meters per second, okay? Now, how are we going to work out the acceleration at this first 3 seconds? What we're going to do is, remember what I said before. If this is a function of time, right? V is a function of time. The acceleration is the gradient, okay? So therefore, A is going to be the change in velocity over the change in time. So therefore, the answer, the gradient is going to be 10 minus 10 over 3, right? Or you can use 3.33. I'm just going to use fractions because I know that this is 10 over 3. And we know it takes 3 seconds, so it's over 3. So if we plug that into our calculators, we get an answer of 2.22 meters per second squared. And that is your final answer. We use the area to work out the distance, and we use the gradient to work out acceleration. Is this still not making any sense? Well, you can join my Discord server and ask me whatever questions you want down below for fast responses. Now let's get on with the third and final question of the day. A train starts from station X with constant acceleration 0.6 meters per second. Lasts for 20 seconds. The velocity has reached 20 and is maintained for t seconds, and then it decelerates for a further 40 seconds, stopping at train station Y. Now let's draw a velocity time graph for this. So, okay, there's quite a lot of information, so let's take our time with it. Where this is v, this is t, no, this is in meters per second, and this is in seconds. Cool. We know that it starts from rest, okay? It starts from station X, so it starts from origin. We now draw a line with gradient 0.6, okay? So this is gradient 0.6. You shouldn't really call it, I'm just going to call it grad equals 0.6. And we know this is 20 seconds. Now, it moves at constant speed, which means now it's flat, right? And it maintains that for t seconds. So this is 20 plus t seconds, okay? I'm going to extend this line quickly. So, same thing, right? Only this time now, it's going to decelerate a further 40 seconds. So it's going to go something like this. And this is 20 plus 40 plus t, which is 60 plus t seconds. Okay? And that is what the graph should look like. The question is how we're going to use the graph to work out what t is. Well, we know that the gradient is 0.6, isn't it? So therefore, the acceleration is the change in velocity over the change in time, which means that 0.6 is equal to, we know it starts from 0, so it's going to be t over 20, and so therefore t is equal to 20 times 0.6, which is 12 meters per second, okay? Now, that's the velocity here. The question is how long will it last from here to here? Well, first let's label that as 12. And sorry, bit of information that we needed that I forgot to read out before. We know that the distance between stations is 4.2, which means the total area is equal to 4.2. Now we can model that, okay? So, 12 times 20 over 2 plus, we know that this distance here is t. So, t times 12 plus, and then this we know from here to here is 40. So 40 times 12 over 2. That's all equal to 4,200, okay? Because this is in meters per second. And this is in kilometers, okay? Now, all we need to do is simplify that. So, 12 times 20 over 2 is 120. T times 12 is 12t. 40 times 12 over 2 is equal to 240. And that's all equal to 4,200, okay? Now let's minus this, right? So 12t is equal to 4,200 minus 360, 3,840. And so therefore, we know that t is equal to that divided by 12, which is 320 seconds. Quite a long time. Quite a long time between stations, but that sounds about right. Now, how long did the train travel? Oh, sorry, no, the distance the train traveled while moving at constant velocity. The point at which it moved at constant velocity was here, right? That distance is equal to t, which is 320, times 12. Okay? So 320 times 12, you can put that into your calculator, and you get an answer of 3,840 meters. And that is your final answer. Thank you guys for watching. I hope this video made sense. Do you guys want to pass your exams with flying colors? Well, you can get tutored by me. Drop me an email to organize a meeting and a quote. Keep on learning, as you have no idea what you're capable of doing.